AI agent.
AI agents.
AI agent.
AI agents.
AI agent.
AI agent.
AI.
Everyone's building AI agents. But what if your AI assistant is also an interview prep tool that doesn't just test you, but remembered your answers, understood your weaknesses, and evolved with you like a real coach? Forget static PDFs and GitHub questions. Is a fully autonomous AI coach that adapts to you in real time. This isn't just another chatbot. It's an AI-powered interview assistant that reasons, adapts, and guides you like a human mentor. If Tesla can drive itself, why can't your interview prep be smart enough to drive your learning? Meet the ML Interview Assistant.
Welcome everyone to this masterclass sessions hosted by Interview Kickstart. Thank you for joining us today to hear about the topic, how to build a personalized ML interview assistant. Now, this is an AI application, and I'll just be giving you a quick overview as to what it took me to build this personalized ML interview assistant, ML AMP for short. I'm an instructor with IK, and some of the concepts, I will cover some of the concepts in the context of AMP in this masterclass, but for a further deep dive to ramp up and to build breadth, I would encourage you to attend the IK classes and sessions to build that in-depth knowledge. I'll just be presenting the application, hoping it serves as a motivation for you. If I can build an agentic AI application, so can you if you're enabled with the right building blocks that IK helps provide. Right? So let's get into the topic itself, right? We are looking at a power-packed agenda. I've broken down this session into 4 digestible parts. Part 1 or segment 1, I'm going to be talking about what is ML AMP? What is an personalized adaptive ML interview assistant? What is it all about? What motivated me to build it and why, right? And when we think about what were some of the concepts that I had to build my knowledge on to build such an application, an agentic AI-powered application, I had to look at, I've used AI agents, I've used personalization, and I'm using fine-tuned LLMs, right? Large language models. Segment 2, I'll be diving in deeper into the how did ML AMP, how did I go about building the personalization and the adaptive layers? When we think about standing up any ML application, in this context, ML AMP, we should think about pipelines, right? Data collection pipelines, data ingestion pipelines, data processing pipelines, training and evaluation pipelines, finally providing the context-aware inference that you will see today with ML AMP. Now, ML goes beyond the chatbots, the conversational chatbots, and RAG. RAG is one small aspect. It's one agent in this whole piece, in this whole application infrastructure. You will look at what it took me to make it production ready. Right? What were some of the workflows I used, diving into a little more of the how, and specifically focused on what it took me to make it production ready. Okay, so that coming in from a software engineering background, this should sound very familiar, but this has another wrapper on top added to it, which is how do you make an application that leverages ML models production ready, right? So that will be the focus of segment 3. For segment 4, I'm going to follow it up with a live demo. So you see ML AMP to see how it's working as an AI-powered interview coach, helping you prepare, helping you bridge your knowledge gaps, level up, skill up, and prepare for ML interviews if that is your goal. Okay. Without much further ado, let's get started. I'll introduce myself. I'm Dipti. I've already mentioned I'm an instructor with Interview Kickstart. I've had over 2 decades in the software engineering industry now, building and leading engineering teams, transforming business challenges into solutions, into impactful solutions that deliver value to the businesses that I've been part of. For me, it was all about taking vision, a product vision roadmaps, translating them into the technical execution strategy, executing myself, doing so with a team, and delivering for each of the orgs that I've been part of. This way, I've driven innovation, I've solved complex problems, all focused on the engineering side of the house. I've worked around most of the applications that I've built, I have delivered on. These were ML applications that I did the engineering for, right? Focused on latency, scale, making the applications that leverage the models production ready. I spent a large part of my time at Amazon for about 6 years building fraud and risk applications. At GoodRx, I was building their identity graph. It uses US Neptune. These are knowledge graphs for resolving multiple account identifiers. My last fractional CTO engagement, I took that a step further. I built the graph neural network models that do identity match and merge multiple identity records into one golden identity. I did that. I built the graph neural network myself and hosted it and stored the model, made it ready for inference as part of the solution that I delivered as a fractional CTO. This was after my transition into being an AI and ML architect, after having primarily been on the software engineering space as a principal software engineer for over 2 decades, right? So that's my ML transition in short. On the academic front, I have a master's in computer science from Arizona State. More recently, I've been following it up to build on my AI ML expertise and its skill set. Followed it up with graduate programs in UC Berkeley that I wrapped up last year. This year, currently pursuing an AI graduate programs at Carnegie Mellon University. My current focus is on building multimodal applications. All interesting and exciting, right? But it is a lot of work and effort. So I did want to call that out. Upskilling always is, right? So that's it about me in a nutshell. Let's get started with the part one. I think I spoke about the part one being the what and the why focused. It's going to talk about the what is ML and the why I went about building it. And that's what our next few slides are going to be focused on. All right. So what you'll see today, you're going to be looking at an AMP. It is an AI interview coach that is powered by fine-tuned LLMs that remembers every question that you've answered in the past and presents your next practice session based on how you answered in the past, what skills you mastered, and what skills you need to keep adding upon, like adding and building upon, right? So it'll watch it, catch that you struggle with bias, variance, trade-off questions. Perhaps you excel at neural networks, and your next practice session will be geared towards what skill you want to master to learn that ML role, or perhaps even to build your knowledge going forward if landing an ML role is not your immediate focus. So how does an AMP work? It does so by adaptive learning. I've been talking about personalization and adaptive learning. So personalization is the questions that are presented to you in the practice session. It's content or questions tailored to your skill level. It's also adapting in real time in the sense that it presents a question, looks at your performance based on the difficulty of the question that was presented to you, and adjusts the difficulty based for the next question based on how you answered the previous. So in terms of your skill set and what you will walk away after this masterclass, you'll have a complete learning loop. You'll see an ML agentic AI application in action. You'll see how the data collection, the data ingestion pipeline, the training pipeline, and the personalized real-time inference all work together to deliver this AI interview coach, specifically focused on ML knowledge building as well as interview preps. All right. So hopefully that I've given you a good motivation into what we'll be talking about for the remainder of the session. All right. So I'm pretty sure all of you have interacted with LLMs. What is the first thing that comes to your mind when you think about LLMs, short for large language models, chatbots, right? I know this came to most of you, if not all, chatbots. ChatGPT is one such example where you directly interact with chatbot. You ask ChatGPT any question, and there you go. You get the response. ChatGPT is talking to its models, GPT-4 or GPT 3.5, whatever version ChatGPT is running with, whatever model version it's running with, and it responds to you with questions, right? So that is your use case one, correct? And your use case one is essentially your use case one is focused on direct interaction with chatbots. Okay. Now, my second use case that comes to mind, the way that you would interact, you as a user or a learner would interact with LLMs is, again, I'll take another ChatGPT example. Let's say you ask ChatGPT, hey, can you give me an image of something, right? And ChatGPT interprets your request, it formulates that request and sends it off to its own image generation model. Maybe it's DALI, right? Or some other image generation model that ChatGPT is currently working with. And then you get the image that is rendered to you in response to your user request. All of those, the ChatGPT intercepting your request, sending it off to its image generation model, all of it was transparent to you, right? All that you saw was you put in the request, you got the image, right? That is use case two. That's another way of interacting with LLMs. And I call this as proxy agent interaction. Okay. The use case three, I'm sure you've all seen it and you've all observed it. Maybe it hasn't struck a bell, but I wanted to call it out explicitly to make sure the next time you see it, you're able to associate and map it to use case three, which is an agent acting on behalf of the user. So I'm located in San Diego, by the way. And if I were to ask ChatGPT, what is the weather today in San Diego? It is likely going to tell me, hey, I don't have that information because I've been trained with a static static data, and I don't have what's the weather today based in your location. But do you want me to do a web search, or better yet, reach out to a weather service and get you that information? I say yes. And lo and behold, ChatGPT presents that the weather today in San Diego is nice and sunny. It's 75 degrees Fahrenheit outside. Nice day for a walk. And that's it, right? Use case three, this is an agent acting on behalf of the user. Agent acting on behalf of the user. Now, there's yet another use case for another way in which we interact with LLMs. And this is, if you think about self-driving agents, Tesla, right? The disruptor in standing up self-driving mechanism in cars. What is it doing? It's completely autonomous, right? The self-driving mechanism in Teslas, it's doing so completely without taking any instruction from the user, right? It's observing, it's looking at the environment in which the car is operating in. It knows the car's surroundings, right? Car ahead in front of you. There's no car on your right lane. There's no car on your left lane, or you need to brake, right? That's the environment in front of you. Now, the actions it takes are it needs to make a left turn, and your car needs to make a right turn, or maybe you see and the car sees a stop sign and it needs to stop, right? Those are actions that are being taken independent of the user, right? From the observations that are happening of the space around the car, the environment that the car is in. And to do what? Why would you self-drive? Why is a car self-driving? To get you, the user or the driver or the passenger, from point A to point B, right? From your source to your destination. Now, these are completely autonomous agents, right? Autonomous agents that are reasoning, it's acting, and it's observing the space, the environment to figure out how to achieve the goal, correct? So four different interactions with LLMs. And ML today, why did I bring this up? ML today resides in this autonomous agent world, right? ML uses a couple of agents, not a couple, 7 or 8 of them to be precise, all of them working together to help with building up or leveling, to help you as a learner level up in your ML knowledge base, or to help you prepare for ML focused interviews. Okay. So ML's vision is to transform static interview preparation rather than using static resources like GitHub, static question answers. Maybe you found them on some online resource. Rather than using static resources, it transforms the interview prep or knowledge building into a personalized adaptive experience. And the static becomes smart, right? It's adding to the its knowledge base, and it's presenting it's personalizing your experience, your learning journey based on your skill level, and it's adapting based on your performance in real time. Okay, so that's what you're going to explore. How did I go about building ML amp? I used fully autonomous agents. I used the React patterns. I'll talk about React patterns shortly. I used a RAG component, and I used personalization at scale. We are going to experience ML AMP in action, the AI-powered system that remembers and adapts to each learner's performance and their learning journey. Okay, so you're going to see all of it. I wanted to set the context up as we get into the next couple of slides here. All right, so this is my case study outline. I'm giving you this as a mental model and as a basically to structure the next few slides into what I'll be talking about. I've already covered ML AMP as a solution to static interview preps. I'll be going a little bit into that challenge in the next slide. I'll be talking about what does it mean by agents? What does it mean by workflows? So ML AMP, I use an autonomous decision-making framework where all of these agents are working together autonomously, right? They use user context, they use the learner's performance history to make real-time decisions in terms of what is the next question that I need to serve to the user. What is their performance? How is this user doing? Are they ramping up on their skills? Are they ready to move on to the next skill level? Okay, so I'll be talking about agents versus workflow, and this is a gentle introduction into the decision-making frameworks that are out there. MLM specifically uses LangGraph, and we'll deep dive into that a little bit as well as part of that. MLM's agentic decision making. Now, I spoke about agents. They are working together in an intelligent learning loop. And we'll see what that intelligent learning loop is. And that is what is enabling MLM's real-time adaptation and personalization. Okay, and we'll see what that exactly is. And then the MLM solution overview, I'm going to be talking about how it does its multi-layer routing, basically directing a learner to a model A or a model B based on whether they're looking for detailed context or just a brief response, and how this is coming together and building that adaptive layer. Okay, all right. So let's look at the first block. The first block is the challenge. I think this goes into a lot of the whys behind ML AMP, right? I've addressed this briefly, but let's look at it. Let's dig a little bit deeper into it. Our ML interviews today, if interview prep is our goal, or if it's knowledge building, let's consider both, right? They demand our expertise across statistics, algorithms, architectures, right? Model architectures. That's what I mean by that. Latest emerging research. It's a breadth that's impossible to cover it's impossible to master with static resources. Interviewers are not looking for just the breadth. It's also the depth, right? Depth of the topic. How much of it that you as a candidate or a learner are aware of. So how do we build an AI system that covers this technical complexity with accuracy? I can't have ML hallucinating and giving you incorrect answers, right? Because that just means I'm not aiding you in your learning journey in any way, nor helping you with the interview prep, correct? So this system should cover the technical complexity with accuracy. It should help you build and cover the breadth as well as the depth, but it needs to adapt to each of the candidate or the learner's knowledge gaps and your own learning pace, right? So that's primarily my motivation behind standing up ML AMP as this agentic AI application that's able to bridge the individual learning gaps and dynamically evolve, right? Keeping up to speed with the emerging ML space. It's been hard for me to keep up, in fact. And making sure that the interview prep, you're focused on interview prep in the right direction as it's evolving rapidly today. All right, so let's get into the next pieces. I've spoken about ML primarily as an agentic AI application. Now, in case of any ML powered system, including an agentic AI application, there are three layers that go in. And this is ML's take on how it covered the three layers, right? So think of it as a triangle, right? Infrastructure is one triangle, it's at the bottommost layer. For infrastructure for for MAMP, I had both ML Ops as a foundation layer as well as DevOps. What did ML Ops cover? ML Ops was model optimization. All the LLMs that I had fine-tuned, right? I was using now would be a good segue. I'm using open source LLMs, right? I'm not using closed LLMs. By that I mean these are not just API calls to existing foundation models. I have taken open source LLMs and I've fine-tuned them on the ML domain. I fine-tuned them specifically on the ML domain. Okay. And the models that I fine-tuned, I had to host it, right? To get keeping in mind model optimization, the model inference, because latency is a concern. So that's where ML ops comes into play. One of the aspects of ML ops is how do I account for model inference and optimizations? I've deployed it in Hugging Face endpoints, Hugging Face inference endpoint that leverages that comes in-house with the model inference optimizations that I needed to give me the latency that I was looking for. Okay. Now, the other ML ops pieces that I factored in is how do I do user profiling for the adaptive and the personalization aspect of it? I used a SQLite DB. I've used a vector search, right? We have a large number of ways in which we can do vector search. I've used Face, that's short for Facebook AI, for similarity search. And I've done model management. I've used data registry, running experimentation and tracking by using model registry, by using a specific model registry. My DevOps foundation, I've packaged this application using Docker containers with Docker Compose, and ML AMP is served behind an application load balancer, SSL and HTTPS on EC2. Okay, and my model layer. This is where the fine-tuned LLMs come into the play. I've used fine-tuned LLMs. I've used LangGraph. This is for the workflow orchestration. Remember, I've been talking about ML AMP as being an agentic AI application. Now you have agents working together and they're orchestrated in a LangGraph workflow. We'll talk about what's the difference between agents and workflows, if that's a question that's coming to you shortly in the next couple of slides. Okay. And I've also provided the real-time analytics to assess a user's performance in the course of a practice session, right? And to keep track of their 360 degrees learning journey in terms of their skill assessment. My application layer, I've used Streamlit to serve up the real-time, the inference layer with the UI components of it. You'll see all this in action in the demo segment. This is just a gentle introduction into what were the three layers that ML AMP leveraged to stand itself up as an agentic AI application. So what does it mean by true agentic AI architecture? I've been talking about the user and being an agentic AI application. What does it mean by that, right? When we think about a generic AI workflow, a user provides a prompt. The model, it generates some completion based on the patterns that it has learned during its training. Okay. And the response is delivered to the user. So it's just a single turn interaction. There's no persistence, no ability to act outside the conversation. That's what the traditional AI systems have focused on, right? It's when you think about your conversations with ChatGPT, that's pretty much where we are, right? Maybe there is some session history that's being managed, but not much. So there is no intelligence. It's not learning from your user. It's not learning from the. It's not learning, and it's not giving you a personalized and an adaptive experience, right? It's not reasoning. It's not decision. It's not. It's not calling other tools dynamically, right? There's no React component to it. I'll talk about what React means shortly. And this is where we see ML as a shift into the true agentic AI space. It works in an autonomous fashion. It's a fully autonomous system. It makes decisions, independent decisions at that. It's learning from the users or the learners' past performance, and it's continuously improving personalization, and it's getting smarter, and it's learning more about the user's skill level at every turn, at every interaction, right? So this is a true agentic artificial general intelligence system. Okay. And this represents the whole paradigm shift from a traditional AI to a truly agentic AI world. All right. So, having said that, let's keep looking at what are the agentic capabilities as a true agentic AI system. What are the six core agentic capabilities that ML comes with? It's doing reasoning. What is it doing reasoning on? It's reasoning about the user's need, the context, right? What is their learning profile? And it's learning about their situations independently. Now, I could be interacting with ML AMP in one session. I could have maybe Dipti's friend interacting with ML AMP in another session. So it's reasoning about the Dipti and Dipti's friend independently. Okay. And it's acting on personalized decision. It's acting and it's making decisions based on this autonomous reasoning. It knows what question to serve next in a practice session mode based on whether it's Dipti or Dipti's friend that it's presenting the practice session to. Okay, it observes the outcomes. It looks at how I am performing on my questions and in the context of a practice session, and it learns through every interaction without any explicit training. So these are agents that are working completely autonomously, doing the reasoning, the acting, the observe, the learn, adapt, and improve completely independently. Okay. And I'm using state management. I'm using persistent memory to manage state, as well as I'm using session state information. What does that mean? We'll just get into it in a little bit. Okay. And I'm adapting the next question or the next practice session for Dipti or Dipti's friend autonomously based on based on patterns that ML is learning. Okay, so I've been talking a little bit. I've been talking a lot about agents, workflows, and I've been using these synonymously. But what truly is the difference, right? Now you have workflows, right, which is a set of fixed, predefined steps that you're following through. Think of it as an assembly line, and maybe you're packaging foods, right? So it's packaging some food item, and it's going through a rigid assembly line, one step after the other. There's no out of sequence steps. It's reliable. It gets the job done. The food is packaged, ready to ship, right? It's flexible. It's reliable, but not flexible. Whereas in case of agents, these are dynamic and adaptive, and it's deciding what to do next based on reasoning. And then it's figuring out what its next action should be based on the previous chain of thought. Okay. And these agents are adapting, learning, making decisions all automatically. So it's like an intelligent assistant. So if I were to put this on this kind of a graph, let's say these are workflows and these are agents. Agents are completely autonomous, which means we have full control. Agents are completely in control of reasoning and acting on those observations. Okay, so this is agents have a high degree of control. Whereas in case of workflows, you will see that if you put this as application reliability, and this is low reliability, and this is high, you'll see that workflows have a high degree of reliability. So agents are fully autonomous, they are fully in control because of their reasoning, adapting, right? And they're both of them are they are automating tasks for us, but they are operating in fundamentally different ways. And an agentic AI application like ML is bringing the two together in an agentic workflow. Okay, and that's the best of both worlds that an AMP is tapping into as an agentic AI application. Let's talk about a little bit of the reason and act. I'm pretty sure all of you have heard about React patterns. Now, React it is, and when you think about agents, AI agents, there are about 5 different patterns that AI agents operate in. React is one of the more popular patterns of AI agents, which is a React is nothing but it's synonymous with tight synergy between React, between reasoning and acting. Okay, so let me give you this analogy, right? It's very similar to how we as humans function, right? If you're, let's say you're cooking and I'm making a pasta dish in the kitchen, and I'm not performing my actions randomly, nor am I doing it, mindlessly, right? I'm basically reasoning. It could be that I've already cut all the veggies and I've got a pot ready on the cooktop, and the water is boiling. Okay. Now to put everything together, to get the veggies together, I need to saute it in a saucepan, right? And I need the pepper shaker. Okay. So I reason. That is my first reasoning step. Out of the many, by the way, let me take that back. It's not my first reasoning step. There could be multiple reasoning steps, and perhaps in this current step, I realize that I need the pepper shaker. I reason that I need the pepper shaker. All right. So should I go check my cabinet one? That's my action, right? I then observe. Okay. Well, I'm looking for a pepper shaker. I'm not finding the pepper shaker. I find a vase. Is that enough to saute the ingredients? Well, no. So I have to adjust my plan, right? So I come back to reasoning again. Well, I haven't found the pepper shaker. What do I do next, right? And this is a continuous cycle, right? And this is what allows the agents to reason, observe, and handle unexpected situations, correct mistakes, and dynamically adjust its plans, right? Without any human intervention. And this is why AI agents with a React pattern, this is what is driving the autonomous behavior of AI agents. Okay, so just a little bit of background into AI agents and its most common pattern, that of using a tight synergy between reasoning and acting. All right, so now how does ML AMP leverage these AI agents? I have spoken about this being an agentic AI workflow, correct? And I've spoken about ML AMP leveraging about 7 to 8 such AI agents all working together. Okay, AI agents all working together using the React pattern in action for its continuous learning loops. This is one snippet. This is one of my agents. I call it's called the personalized routing agent. What is this doing? It's reasoning based on the user profile level. Let's say Dipti. Dipti is a beginner in the topic neural networks. I'm reasoning. I'm saying this is the T skill level, and this is the topic. Since she's a beginner, she needs structured support. Cool. What is my action? Make a routing decision. I'm going to route all of these questions in neural networks to model B, which uses structured prompts. Okay, so that's its action, right? This personalized routing agent is observing what my skill level is. It's reasoning through my skill level and the topic that I'm looking at building my skill set into. And then it acts by making the routing decision. Then it observes my performance, and that feeds back into the future decisions. Okay, so the next interaction, it's probably updating how Dipti as a beginner on the neural network topic performed, or having been routed to model B versus model A. Okay, and that's the observation that it's making, and it's recording that to be able to guide its future, to guide the future decisions. Okay, so in short, the key takeaways: ML AMP uses 7 to 8 AI agents. One of them is the personalized routing agent. That personalized routing agent is doing a skill analysis. It's acting on historical data patterns. It's observing and it's adapting. It's observing my weakness areas and it's doing a topic adaptation. And then it's setting up a continuous learning loop to record what model I was directed toward for a given topic and how did I perform on it. So it's basically adding to my user profile. Okay, so that's one agent in action. In ML, it's using a 4-layer decision-making process. Okay, so I just wanted to show you this particular snippet. So let's look at the next slide. I've spoken about NLAM's agents, and I just dive deep into the personalized routing agent as an example. Now, I also use LangGraph workflows to orchestrate all of these agents so they are working together within MLAM's AI-powered interview prep system. MLAMP has 2 modes that it operates in: a question answering mode, okay, and a practice session mode. You'll see these in actions when I do the demo, but I wanted to quickly give you some context as I talk about how MLAMP is using LangGraph workflows with the agents to enable to drive these 2 modes for a given learner. Now, in case of LangGraphs, a couple of quick things, a couple of quick background into LangGraphs. At the heart of LangGraph, right now, LangGraph is a very popular framework. It's used for designing complex agentic applications, and MLAMP is tapping into it's leveraging LangGraph. Why is it leveraging LangGraph? What is good or what is beneficial about LangGraph? At the heart of any LangGraph application is the state. We can think of state as the memory or the current status of any agent's task. This state gets passed along as the agent is moving through different steps in the workflow. Okay, and each step, the agent could be adding information. It can be reading information from the state, or it can be adding new information to it. So the agent always knows what has happened and what information it has gathered. But what is the other important aspect that LangGraph provides us with? LangGraph, it's, as the name indicates, it is a graph of nodes and edges. Each node is performing a specific task, and you have edges. So think of it as nodes with edges with various transitions, okay? And each edge, you can have conditional edges, and that's what makes LangGraphs very powerful. Okay, the fact that there are multiple conditional edges, which allows these nodes to transition from one node to the other, performing different tasks. Okay, and that's what I tap into that's what I tap into as part of ML AMP's agentic workflow. Okay, now LangGraphs also provides memory management, which can be short-term memory or long-term memory. For long-term, I think I've already mentioned this. I use SQLite, and for short-term memory, it's session management, and I'm using LangGraph state to maintain the memory across the different user interactions and one user interaction within a given session. And this is what I'm using for continuous learning. LangGraphs also allow for tool integration, and I've leveraged this within ML to integrate the RAG vector search tool. in one of my agents. RAG is not the whole focus of MLAMP. I want to call that out if I've already mentioned it before. RAG is not the sole focus. It's one of the tools that the agentic workflow leverages in both the QA mode as well as in the learner's practice session mode. And LangGraph easily allows for tool integrations, and that's what I've tapped into via MLAMP. All right. So now MLAMP has an 8-step with its agentic workflow using agents together with workflows. It's using the agents for the autonomous decision making and workflows for reliability, right? It's using that for sequencing the set of tasks that ML needs to perform when in the QA mode or when in the practice mode. Okay, so it's using an 8-step learning cycle. So it takes in the user input. That's the very first step in the cycle. It assesses the user's skill level and infers their learning needs based on their previous performance. Then it does the dynamic routing. We saw in the example of the personalized routing agent, right? That is dynamic routing, selecting a model based on the user context using a multi-layered decision making. Then it's also adapting the context. Maybe I am a learner that needs a more detailed explanation. So I'm adapting this particular agent in this 8-step learning cycle. It adjusts the cognitive load balance for the learner based on their needs. Then the response generation agent is generating an explanation based on the learner's style, catering to the learner's style, with enough depth and examples. Now, once the learner has responded in the practice mode, let's say they've answered a question, then there's an agent that evaluates their answer and figures out how close were they in terms of understanding with the expected response. Okay, and this is primarily used in the practice mode. Now, we have profile updates that goes on both in the QA mode as well as in the practice mode. All of these together forms the learning where the user is being consistently assessed and being routed to the right model. The context is being adapted based on their learning needs, response generated accordingly, evaluated as well to see how their responses matched up to the expected response, and their profile is being updated to record their performance for the current question in a practice session. Right? So this is the 8-step learning cycle, and this covers how MLAMP is using the agentic workflow, leveraging both LangGraph as well as AI agents with that React pattern. All right, so this goes in a little more into each of the agents, the user assessment agent, the dynamic routing agent. Just to quickly give you an overview, the user assessment agent is doing a skill level analysis. It's doing learning needs inference and providing personalized pathways, and hence it's continuously able to adapt based on the learner's needs and autonomously profile the user. No interaction whatsoever on behalf from the user. All of this is happening as part of the user assessment agent in the workflow. Dynamic routing, I already showed you that snippet in terms of how the multi-layer decision making is happening. There's skill-based routing, there is performance analysis, topic-specific adaptation, continuous optimization to guide the set of questions that need to be presented to the user in this practice mode. All right. And then similarly, in the adaptive context agent, it's balancing the cognitive load presented to the learner based on what their individual preferences are. Do they need a detailed response? Do they need a brief response? And it's adjusting to the learner's pace and their difficulty. So all of this put together is forming the persistent learning cycle where the learning trajectory is being optimized for the learner, their profile is evolving continuously, and their skills are being tracked to see whether they're developing along in a given skill level to provide that personalized experience. All right. So now this concludes the part one. In part two, we'll be talking about we'll be going a little more into the how that I just presented, I'll be talking about the architecture in terms of how I achieved personalization at scale through ML app. All right, welcome back to part 3. Before we get into the architecture deep dive, I wanted to build on the how that we've covered. I've shown a sneak peek in my part 1 of this talk. I wanted to showcase some code snippets. So all of us have the same mental model in terms of how ML AMP is working behind the scenes. Okay, so let's look at the code, some of the code snippets of the AI agents being orchestrated in ML Lang workflows. So we've just covered in part 1, we've covered how ML AMP has been stood up as an agentic AI application with LangGraph workflows, and it's orchestrating these LangGraph workflows are orchestrating a bunch of these 7 or 8 of these agents all working together. Okay, so mapping it to the code snippets. This is my main coordinator that's orchestrating the 3 different LangGraph workflows that I have. One workflow in the QA mode, question answering mode, and there are 2 workflows in the practice mode, all coordinated by the personalized assistant workflow that you're seeing out here on my screen. These are the agents that are in use, the personalized in the 8-step learning cycle that we looked at in the slide deck. We had the 8-step learning cycle where I spoke through the AI agents in action, do all of them reasoning, acting, and dynamically taking actions and making decisions for the user, for the learner, all automatically, all in real time. So the agents, you see those agents here in action: personalized user analysis agent, the personalized routing agent, the question generation agent, the personalized context agent, response generation, the semantic, the answer evaluation agent, which is looking at what has the learner provided as their answer for a given question, and is it how close is it to the expected response. That's the BERT score evaluation agent. And then the profile update agent, which is essentially doing that little bit of a loop where it updates the user's profile and records a learner's performance on the questions that are being presented based on the skill that is being evaluated in a given practice session. Now, these are the 2 workflows that are being initiated. Now, all of these agents are being used across both the QA LangGraph workflow as well as the practice mode workflow. There's a third workflow, which is the answer evaluation workflow. Let me see if I can walk you through that. It's the evaluate answer. So this is the practice workflow, which is a LangGraph that's being started. You can see all the nodes in here, and these call into the agents to execute the task. This is specifically the practice workflow. And I wanted to show you the evaluation workflow. The evaluation workflow is coming in at this point. It's evaluating the responses generated by the user. Let me see. There we go. So if the response provided by a learner or the user needs to be evaluated, then we kick off the third workflow in the practice mode. It's called the evaluate answer workflow. And this is what you're seeing in here. Okay, so just to recap, what I'm showing you are code snippets that is mapping the information that I shared on the slides to show you how ML agentic workflow is being orchestrated by the 3 different graph workflows here. Now, these are my agents. They're all working in conjunction. They're working in close collaboration with each other. This is just one example, but agents.py is a collection of all of these 7 or 8 agents working in close coordination with each other. This is the LangGraph's agent state that I'm maintaining. There are a couple of other LangGraph state information that I'm using. In addition to the personalized agent state, I have routing decisions, question selection criteria, personalization context, learning analytics. This is to present how the user is evolving in their learning journey. I will map it to the demo shortly. So this should give you a quick idea as to how the slides map to the code 1:1. Now we're going to be looking at part 2, which is the architecture deep dive, right? So thus far, what have I covered? Again, another recap. I've spoken about what and the why. Specifically, the why was what motivated me to build this agentic AI application. What is MLAMP has been stood up as an agentic AI application with LangGraph workflows, right? And we looked at spoke through the slides in terms of how what had been orchestrated, right? So it was a sneak peek into the how and mapped it to the code snippets that make it possible. Okay, so now let's get in a little more into the how, and this is from an architectural perspective, right? And I'm presenting this, I'm sharing this how from an architecture standpoint, mainly because when we think about engineering any ML application, it is the three layered, the three triangles that you have to keep in mind, right? This is infra, this is the model, and then this is the application layer that all need to be architected and working together to power an end-to-end system. And in the context of ML, we'll see how this has been done through the use of both a combination of offline pipelines as well as the real-time inference pipeline. Okay, enough said. Let's get into the architecture diagram. All right. So this might look very busy. This visual might look very busy. It has a lot going on, mainly because these were the pieces that went into standing up the end-to-end personalized ML interview assistant. This piece that you see here is the data ingestion pipeline, which encompasses data collection and data processing. Now I'm training LLMs, right? I've taken the open source LLMs and I've trained a retrieval model. By trained, I mean I fine-tuned a retrieval model and I fine-tuned a generation model. Okay. And to be able to train the retrieval model, I had to generate synthetic data. There's an elaborate training pipeline for it. I won't go into the specifics, but I wanted you to have that visual that data to train these models or fine tune these models. The post training process involved data set preparation as well. Okay, so I have the training data registry here, and I also trained the generation model and evaluated each of the models, the retriever that I trained as part of this and the generation model that I trained were all evaluated in an offline mode before I chose to deploy the best of these models into production, right? And I used 1DB as my model registry. This is an experimentation tracking framework. It also stores model artifacts. I leveraged that before I hosted the best model in production in the Hugging Face inference endpoints. And I can show you the Hugging Face inference endpoints here of these models since I'm at this stage. So these are the retrieval models, the two retrieval models, and my generation model, which was where I fine-tuned a Llama 3.1 8B model on the ML domain dataset. All right, so pipeline. So I spoke about the architecture, the pipeline, the training pipeline, and the models that form my LLM inference pipeline. Now, this is my application layer. This piece that you see, this segment in here, this is my application layer, which I'll be demoing shortly to you. This shows the LangGraph workflows in the QA mode and the practice mode with the 7 or 8 agents all working in close coordination with each other to deliver personalization at scale. okay, for adapting it to the learner's skills and their evolving needs. There's a lot of specifics in here. Memory that the agentic workflow is managing, short-term as well as long-term memory. And these are the inner components that is being leveraged by the agentic workflows. I'll just leave you with these big blocks to show you what went in there. And then I have the UI layer. The UI is what you will be seeing. This is stood up with Streamlit. And then this is my real-time observability pipeline. So it's not, when we think about standing up any ML application in production, one guideline here is also to stand up the real-time observability. For those of us coming in from a software engineering background, we all know the importance of metrics, monitoring, right? Similarly, here, the observability is both the monitoring as well as continuously evaluating whether the agentic workflow together with the models that it's using for inference, they're all working together without any drift, and they're serving the learner's needs and helping with personalized ML interview prep. Okay, so these are the various pipelines that went in, and I wanted to show you give you an overview into the architectural pieces. Moving to the next piece, this is an example. Like I mentioned, one coordination workflow, right? And three LangGraph workflows, one for the QA mode and two for the practice mode. The practice mode involves the adaptive question generation as well as the response that the learner puts in, evaluation of it to see how close or how has the learner understood is the learner's response close to the expected one. Okay, and this is an example of the LangGraph workflows routing decision. This shows the transitions between the nodes via the edges that allow the nodes to be transitioning, right? And I'm using the state, the LangGraph state to manage those evaluations, to manage those transitions between the nodes as well. Okay, so this is a small snippet which shows the LangGraph workflow routing decision that happens in both the QA mode as well as in the practice mode. Okay, moving to my next slide. This is my QA LangGraph workflow. And to walk through this in a step-by-step fashion, the user asks a question, right? And the QA, I'm going to show you this in the demo, but for now, I'm just walking through how these agents were working together, each performing their own task and transitioning based on what was the observation made and how was the state changed by each agent acting to respond to the user asking a question, right? So first I have the user analysis going on, followed by personalized routing, each of them doing their own react, act, observe pattern, following the react, observe, act, and observe pattern. Then I have the context optimized. This is the retrieval model in play, right? This is the retrieval augmentation piece. Both of these agents take care of the RAG pieces of it. And if there's an update needed to the profile, the update profile agent takes care of it. If not, then there is a personalized response that is returned to the user. Okay, so all of these agents are working together in close coordination to respond to the user asking a question in the QA mode. This is a workflow with these agents working together. Just reiterating how this is working, how that was working in the ML apps context. This is the practice mode workflow. Similarly, agents working together. Now, practice mode, it's a user is starting a practice session. Now, a user is nothing but a learner, right? Learners like you and me. We each have profiles created based on what are our strength areas, what are the areas that we want to grow in, right? And what are some of the challenge or review topics that we also want to cover? So the questions are generated based on, there's a distribution, as you can see here, in terms of how questions are selected and rendered to the user in this practice session. Then the user inputs a response. The response, there is a decision that's going in here. All of this is happening autonomously, by the way. This is all happening through agents. There is no user or learner interaction in any of these steps, right? The user is just involved here, and they start the practice session. All of this goes on dynamically. It's all being done by the couple of agents that are working here. Once the learner puts in their answer, it's evaluated in the evaluation sub workflow, and that's why I mentioned the practice mode had two LangGraph workflows, right? We'll see that in the next slide, and then the profile is updated based on if there was a need for the profile for to track for if the activity for the user had to be tracked. Okay, so that was the first workflow in the practice mode. The second workflow is the answer evaluation. Again, a few agents working together to evaluate what the user has submitted as a response to each question in the Lang practice mode workflow. Okay, so I won't go over each of these, but I wanted to leave a visual in terms of how this is working together. Now, in case of semantic analysis, F1 is a metric that I'm using to gauge the user's understanding with the response that they have input for a given question in the practice session. Okay, and I use BERT score. That's my evaluation metric with F1, recall, and precision all incorporated. This is the BERT score intelligence, and it shows how the F1 is being evaluated. If the F1 is about 0.55, it says there's a need for detail. If the F1 score is greater than 0.85, it lets the user know that they've done an outstanding job on this particular question, and hence the user stands a greater probability of mastering the skill that this practice session is running against. Okay, so that's the gist and the high level idea as to how the evaluation workflow operates. These are each of the agents that are working in these LangGraph workflows. They all have specific roles. For example, the routing agent is analyzing the context and routing to the optimal model based on the learner's needs. It could be it's a model that uses structured prompts to give more detailed responses to the user, or it could be a generic model if they are intermediate, they are advanced users. The model is using a prompt that's giving a high level answer, not the in-depth explanation of it. So that's how I would view the selection, the routing to the optimal model as a model manager. Because you have the RAG pieces working in there, the model manager is what's handling the model switching and the inference. There's an evaluation agent and a personalization agent to maintain user profiles and to handle the adaptive learning experience for the user. So a complete agent delegation flow between these multiple agents working together. Remember, I mentioned when we talk about AI agents, there are about 5 patterns that are leveraged. So this is the multi-agent pattern. Each of these agents in the multi-agent pattern is following the react, the reason, act, and observe pattern within itself. All right. Now we are moving on to what would it take to get this, what did it take for me to get ML production ready? I think I've already covered some of the pieces. I spoke about the real-time observability pipeline. I spoke about the offline evaluations. In addition to that, I had to look at error recovery, standing up error recovery and resilience, right? So again, for some of us that may be coming in with a software engineering background, these should resonate with you, but I want to call it out that the same principles apply more so in in standing up an end-to-end ML application. We need to allow for graceful failure recovery. So for example, if the user is asking for their answer to be evaluated, and for whatever reason, my BERT score model is not running within the BERT score evaluation agent, the answer evaluation agent, then I have implemented graceful failure recoveries, right? The system doesn't hang, right? Think of it as there's no bad user experience, okay? And there is automated error prevention recovery modes. Automatically it recovers because remember, at the end of the day, all of these agents need to ensure continuous operation and service reliability, okay? So I wanted to stress on this particular bucket specifically, learning analytics. Now, this learning analytics is coming from the point of view as to how is the user performing, what are their performance trends, and what are their usage patterns? How have they been practicing? Where are they in the skills? Where are they in their user learning journey based on what skills are being assessed and where they are currently on those skills, right? So we are tracking the usage pattern analysis, also logging. There is some logging and auditability that's going on to track why the user was presented with a given response or why they were evaluated as needs improvement or they're excelling in one area, right? All of that logging and auditability has been built in via the learning analytics module, right? So in addition to the core functionality in the application layer, these were the key areas that I focused on to get ML production ready on the application side of the house. Now, from the infrastructure side of the house, security and compliance. Now, again, security and compliance, this is a no-brainer, right? This is when we think about engineering applications that have stood out with the infrastructure that we stand up. We need to provide enterprise-grade security. There should be no vulnerabilities, right? Data should be protected. The right access control should be in place, ensuring that there is safety, there is safe deployment in production environments. So that's where you see the SSL and HTTPS. The ALD has been enabled with SSL and HTTPS encryption for all data transmission. Okay. I spoke about model state management, right? This is from the point of view of the application. How is it maintaining both the short term and the long term memory, right? So this covers the memory pieces of the application. Scalable deployment. I've used an ALB and there's just a single EC2, right? EC2 is fronted by the ALB, but at any point in time, should MLM start receiving more traffic and there is a need for me to scale, I can very easily switch this out to an ECS or an EKS cluster, right? So that's the auto scaling that I built in from day one. And then I have the real-time analytics to show the performance, in terms of how are the agentic workflows working together, right? The operational health monitoring with alerts. Now I've used Langsmith for this, and I wanted to quickly show you. This is my ML interview assistant, the monitors that I've set up for it. Currently, it's sparse, but this is the initial setup that I have going for it. In my next iteration, this will be much better. But the framework is laid to get it production ready. I've laid the foundations to get it production ready. Okay. So now let's move to the last part 4 of this talk, the segment 4, the live demo itself. Welcome to part 4 of the talk. I'm going to be doing a live demo for ML Agentic AI workflows in action. Without further ado, I'm going to step into the app itself. All right. So this is ML AMP. Like I said, this has been hosted. It's hosted on an EC2 instance, which is fronted by an ALB that has SSL and HTTPS encryption, right? And this is the endpoint that I have set up, I've configured for it. Now, this logs me in as a user. I could be a demo user. I could be a demo user 1. I still don't have the user authentication flows built in yet. That would be my next iteration of ML app. But I have the sessions being managed for each of these user profiles independent of each other. So let's start with user 1, and I'll also go into another user's profile to show you the session management in action. All right, so I'm logged in as a demo user. The demo user's learning profile, they are an intermediate skill level. They've already, up until this point, they've answered about 6 questions. Their success rate has been 66.7%, and their difficulty level with these questions has been easy. And their focus areas is deep learning, right? This is the area that they want to build, that they want to improve their skills on. Okay. And 4 questions from today alone out of the 6 questions that they practiced with. All right. This is how a demo user would manage their profile. They would change their skill level. They would toggle between beginner, intermediate, advanced. The agents also move them along their learning preferences, but this is for the user to explicitly override. If should they need to, they can override their skill level as well. So starting off, let's say demo user is a new learner that's just coming in that's just coming in to practice with MLM. They're gonna start off as perhaps a beginner, right? And they set their preferred topics. Perhaps these are the areas that they've already mastered, but and they use it to, this is basically used to help build confidence, machine learning, and statistics. Now, the areas to improve on, it could be deep learning. Now, remember, machine learning is a whole, it's the breadth, right, of all these areas together with the depth into each of them that we are looking at building our skills, that demo user is looking at building their skills for. So their preferred difficulty, it could be easy, medium, or hard. They're starting off as an intermediate with areas to improve as deep learning, and the preferred difficulty on these questions is easy. Okay, these are their learning goals. So demo user is using MLM mainly for interview prep, ML interview prep, and skill building. They could also be using it for knowledge testing or a concept review, right? Multiple learning goals. They can toggle each of these based on demo users' needs. Okay, the learner's needs. The learning preferences, do they want hints to be shown? Do they want detailed explanations? Do they want their learning progress to be tracked, right? Or do they want to be incognito? It's recommended that they track their learning progress to utilize all the benefits of MLM, right? And then the adaptive difficulty adjustment is also something that they can toggle on or off. All of these are recommended to be turned on, especially if a learner is a first-time user. Okay, so these can be saved. The profile, the demo user's profile is updated. Of course, I did not make any changes from what was already there. So let's get into the QA mode. Like I mentioned, there are 3 LangGraph workflows, right? And they're orchestrated by the main coordination workflow, correct? And I'm stepping into the question answering mode that is driven by just one LangGraph workflow. Now, the practice questions mode is driven by 2 LangGraph workflows, right? So getting into the question answering mode, the user or the learner here, the demo user who's a learner, they have the option of typing in a question. I generally use it when, let's say I have a research question that I want to research on, and I want to pull that information up from the archive papers, right? It's the latest research, something that was published maybe last month in the month of June. It's July for me currently. So I want to look up the question, and I want to do some research on it. I would type the question here. Okay, so let's not use this for the purpose of this demo. Instead, let's go for the questions that are there in this dropdown to showcase how the Q&A mode would work for a demo user. So let's just say they come in and say, all right, I want to know what is the difference between position and recall. They're using this pretty much to learn, right? They are building knowledge or testing knowledge, evaluating the knowledge that they may already know. Or they have a question and they're curious about it and they want to build their skill on this particular question. So they come in, they pose the question, they generate personalized answer. This is a RAG piece. This is the context retrieval agent, right? That's coming into play. In this case, there was no context that was retrieved. The answer was generated mainly from the model's knowledge. You'll see these were the routing decisions that were made. Remember, we had the personalized routing agent that's making a decision based on the user profile, what their skill level was. So it looks like this was routed to model B with a structured prompt. And the context threshold that was chosen was about 0.75. What does that mean? Do they want additional context retrieved? If so, the threshold is 0.75. So how similar should the context be retrieved with, right? That's a similarity score, and we are cutting it off as it should be pretty high, right? We do not want anything that is less relevant to be shown. All right. And this is the personalization that has been applied. And you can see that here based on the routing decision, what were the context optimizations that were applied. Remember, each of these are agents working in the background to do the routing decisions, right? This is after the fact. This is just showing you what has happened after the fact, right? The answer has been generated, and there you see this is your personalized answer. It seems factually correct because of the model evaluation that I've done in the offline model evaluation before I hosted this in Hugging Face inference endpoints. These were the endpoints again, just to make us recollect. Let's go back here. Okay, now let's choose a different question to see if I'm going to be pulling in information from the context. All right, here we go. So we did retrieve some similar passages. The threshold that was used here was a 70% context retrieval threshold. Okay, and you can see that the routing here, it was directed to a model A with a general prompt based on the question type. So this question type. I have question type distinction as well, and that's being used in the routing decision, right? The dynamic routing, remember, it's a multi-layer decision framework that's being followed from the slides, from our earlier slides. That's what is in action here. You'll see that the personalization was applied. There were 3 sources that were found to be relevant. This had a relevance of 0.72, and this had a relevance of 0.71 from my RAG store, where I used FIES for this. And the relevance of this particular document was 0.71, okay, for the question on how does gradient boosting work. All right. That's pretty much the Q&A part. Now, going into some of the options that the user has, they can toggle on or off. They can toggle between, should it be brief, should it be detailed, should it be comprehensive, or do you want the agents to be driving the personalization for the user, deciding on what their user level is, what their profile is, right? I've opted for the personalized to be automated, personalized, right? But there is always an option for the user to toggle between these. And it explains the basic concepts. Now, the context usage, it could be minimal, standard, or extensive, and that's going to change this particular context threshold, and hence it's going to influence the routing decision that's made by the personalized routing agent dynamically. So just to show you how these agents are all working in conjunction and collaboration with each other in the question answering mode. Remember the LangGraph workflow that I showed you in the architecture deep dive slide? This is pretty much all of them working in close coordination with each other to deliver this personalized experience in the Q&A mode for the demo user. Now let's switch the demo user to the practice question mode, right? Now in the practice question mode, the demo user is going to be presented with practice sessions. Now these practice sessions are catered based on what they'd like to focus on, right? In this case, the learning area, the focus area is deep learning, and that's where the focus is going to be. It's going to be adaptive. The questions are going to be leaning towards the deep learning skill. Okay, and this particular user has done another session earlier today. They've had a 66.7% practice rate. They answered 6 questions in the past. 4 alone were answered today. Okay, so that's what it's showing. Now, again, these are options that the user can override practice session settings. The number of questions in this practice session, it can go anywhere between 1 to 15. I'm going to keep it short for this demo. I want to keep it at 3. Now, the session focus, it can be adaptive, or do you want it adaptive in the sense that the agents are going to decide based on what the focus area needs to be? Does demo user only want to focus on weak areas, or on the preferred topics, or go into a challenge mode? So these are all options presented to the learner, right? And this is used by the agents to determine what questions to render in this practice session. Okay, so just showing this as a setting. This is a response evaluation. If they choose not to have their response evaluated, it's fine, right? We can toggle it off, but I want to show you how the responses are evaluated using BERT score, and it's measuring the objective similarity between what demo user enters versus what is the expected response. So we'll see that in action. This was just about the settings itself. So I'm going to start the practice session for the demo user. And in this, I've set 3 questions. You'll see that the first question that's presented is, what is the difference between supervised and unsupervised learning? It's coming from the topic machine learning. And remember, this is an adaptive session, right? It's the agents that are choosing the questions. It's not focused on just the weak areas or the preferred topics. The question selection strategy is distributed across all of these areas when it's the adaptive mode. Okay, just something to keep in mind. I had captured this in the practice mode Q&A workflow. That little workflow as the little visual that I had going where these agents were talking to each other, the question selection strategy here. Okay, so now let's just say I entered the demo user, which is me because I'm operating on behalf of demo user. I enter something gibberish. Okay, now the answer, this is the second workflow that's kicking off. This is the evaluation workflow that is kicking off in the practice mode. This was the question generation workflow. This is the answer evaluation workflow that's kicking off. It's done the evaluation. It presents the metrics, the BERT score metrics, which is precision, recall, the accuracy. And it's also computing the F1 based on the understanding. Since it was gibberish, everything is in negative, the negative metrics, right? Based on completeness, relevance, word overlap, right? Relevance is how relevant was the response that the demo user provided for this question. How complete was this? All negative because of the gibberish that me, on behalf of demo user, put in there. Okay. Now, the demo user also has the option of viewing the reference answer. So let me minimize this. So there we go. They also have the response that is generated. This is again using one of my retrieval models. And these are agents all working together in the evaluation workflow to generate the reference answer should the user click on viewing the expected response. Now the user provides feedback on this question. Now this is also accounted for. So the user can say, okay, did you understand? The user is being asked, did you understand the question? What was the difficulty level? What did you feel? Right? And this is being used by the agents to render the next question in the practice session. I'm going to leave it as is and just continue with this practice session. The next question is how do transformers work and what makes them effective? This is coming from the topic deep learning. Okay. And it also tells you why this question was being selected for you. Right. So there's transparency here. In addition to maintaining the audit trail for the user in terms of tracking their performance, etc., we also are being very transparent as to why this question is being presented to the user in the practice session. Again, gibberish. Okay, same thing. The answer is being evaluated with BERT score. There's always the option to view the reference answer, and the user can provide feedback on what they thought of the question and the response that was provided. Okay, I'm not going to do anything there. Excuse me. I'm going to continue and I'll choose to skip this question, the question 3. So I finished this practice session and now I can go back here and see learning analytics for the user. How did they perform in this particular learning session? Excuse me, sorry, my throat is a bit scratchy. They've been, thus far, over the last 30 days, they've been presented with 52 questions. This is their success rate. What are the topics that they've worked on? What has their success rate been, right? And you can tell that I actively contributed to their success rate dropping to 20% with me typing in gibberish responses for some of those practice questions, right? And this shows the difficulty analysis of the questions, what their recent activity was, and what are the areas for improvement. Okay, and their strengths are apparently it's in deep learning and optimization. This is doing a complete profile view, not just today's practice session, but over time. Okay, so let's close this. And this is the analytics piece. I mentioned that. Let me see. Now there is an option here where I've chosen to either pick locally deployed models on the EC2 instance, or to choose the endpoints, the Hugging Face inference endpoints. Now, should I opt to use the local models? It works great for me when I'm in a development mode and I'm looking at optimizing the costs by not leveraging the Hugging Face endpoints. But it takes about 45 minutes or so for me to just get a response to the question to get them evaluated, right? So it's not optimal. It's okay from a development standpoint when I'm looking at lowering the cost, but to leverage the model inference optimization that I'm getting out of the box with the Hugging Face TGI inference layer, I'd rather choose this configuration setting. So I wanted to briefly explain as to why I chose this option over the other. Okay. And yeah, I think I've covered it. Let me choose another user, switch to being another user. Let me call it demo user. And this is a brand new user. Let's get to their question answering mode. All right. So you can see that there has been a demo user A. All right. Let me see if there is a demo user Z that exists for a brand new user. All right. Let's see what are they set up with. Okay. They're all set up as by default as an intermediate. They have a 50% success rate. This is the default setting, right? Now, this user can go and change their skill level. But the point of showing this switching from demo user to a demo user Z was to show you that these two users, these are two separate users tapping into accessing ML AMP, and they are working with different sessions, right? Which means they have different experiences based on what they are working against. You'll see that they haven't practiced any questions. So you won't see what they practiced with in the past that you saw, unlike what you saw for demo user, for the demo user. Okay. So that's pretty much it. This was a quick run through as to how these users are separated. Okay. And the QA mode and the practice questions mode as well. This completes the demo. I had a local version of it as well. This is the observability, the real-time observability that I'm currently working on. This should be ready for the next iteration of ML AMP. I'll push this to production. I wanted to show you the monitoring pieces that I've stood up, right? Monitoring to ensure that all of the metrics that I'm tracking, the latency, the number of runs that are happening through Langsmith is being tracked, right? I'll be building on this monitoring capabilities in a little bit, but I wanted to show you that this is something that I currently have in my local development box. Takes you to this. It's very sparse at the moment, and this should be ready for the next iteration of MLM. All right, but the framework is there. So yeah, you'll see that the production readiness has taken care of laying out the groundwork. It's just now iterating and improving on the initial delivery. All right, let's go back to the slide deck. So I've concluded the demo and hope you enjoyed viewing ML AMP in action. All right. And just to recap, what did it do, right? It is an AI learning system, and it's remembering every interaction. It's reasoning about the user's knowledge gaps and automatically orchestrating the personalized learning experiences. You saw the ML AMP in action. With LangGraph agents, it uses RAG with fine-tuned models, and the adaptive personalization layers, they're all working together to create that learning, the transforming a static learning, interview learning experience into a smart experience that's evolving with each user or each learner. Okay. And that's pretty much the conclusion of the demo and the recap. Over to the next slide. Thank you for attending today's session. I'm hoping this provides you enough motivation to learn the foundations and the building blocks that are needed to stand up a similar application. If you're motivated enough to stand up a similar application at your end from this talk, I would strongly encourage you to pursue it. Please follow it up with ramping up through the interview Kickstart classes. That's about it. Thank you, folks. I'll let you go now. Thank you all.
Are you ready to future-proof your tech career? Join us for a free live webinar where we'll introduce a powerful 14-week upskilling journey designed specifically for engineers, PMs, and tech leads who want to stay ahead in the Gen AI era. You'll learn how to design, build, and deploy intelligent AI agents that go beyond chatbots, with hands-on projects that deliver real business impact. We start from the ground up, covering the foundations of Agentic AI, then moving into building agents with large language models, adding memory, decision-making, and optimization layers. You'll also get Python essentials tailored for Gen AI, along with deep insights into LLM internals, prompt engineering, and model fine-tuning. Every step is practical. You'll build real tools, like an automated data insights engine, and finish with a capstone project that demonstrates your skills in action. This isn't just theory. You'll learn directly from AI leaders at top tech companies, people who are already shaping the future of work. If you want to build Gen AI expertise that's both practical and in demand, this program is for you. The AI wave has already arrived. Join us and ride it, not get swept away. We'll see you at the webinar.